All right, so you're right. We can't combine this one, but we can't factor either because a factor we have to have cosine of the same exact thing, okay? But, right, we've got cosine minus cosine, don't we? So look at all your different formulas you've got, and where do you have something that's cosine minus cosine?
Right there, cosine minus cosine. Cosine u minus cosine v.
Good. Cosine of u minus cosine of v equals?
2 cosine. Sine, that's what I said.
It's u plus v over 2.
All right. So it told us that formula, right? So what is u going to be? 6x. And what is v going to be?
3x.
All right. So let's see. What do we have here? So we're going to work on this left side. And we're going to rewrite it. So it's negative 2 sine of u plus v over 2. Whoops. Times sine of u minus v over 2, and it's still equal to 0. What now? Yep, work inside the parentheses here. So we got negative 2 sine of 9x over 2 times sine of 3x over 2
Done.
Not done. We haven't solved yet. What can we do now?
Divide by a negative 2 sine.
Well, not negative 2 sine, but I can divide by the negative 2 if you want.
That's what I meant, yes.
Because this left side is all one term. So we got sine of 9x over 2 times sine of 3x over 2 equals 0.
Multiply by 2.
No. Remember before when we did this with multiple angles and angles being divided by a number, you don't deal with that part. We're not going to worry about getting rid of the 9/2 or the 3/2 until the very end.
Take a sine root.
No, can't factor.
You do another formula.
All right, guys, what if all I have there is I have a sine times a sine, right?
Yeah.
So what if I had 2x plus 4 times x minus 1 equals 0? What did we do?
You factor.
No, that is factored. What do we do after we had factored?
Refactor. Always separate and equal to 0.
Set them both equal to 0. Well, I have the same thing here. I have two things being multiplied, so I'm going to set them both equal to 0. All right, so I'm going to erase my little think bubble I just put up here so I have extra room. So we're going to take sine of 9x over 2, set it equal to 0, and sine of 3x over 2, and set it equal to 0. Now in this problem, are we restricted? No. So this is our plus 2 pi n, right?
Correct. Yeah.
All right, so let's see. But I've got my sine by itself. So sine of 9x over 2 equals 0. Sine's by itself. Sine is what, x or y?
Sine is y.
Y. So I'm looking on my unit circle. Where is y equal to 0?
0.
0 and pi.
At 0 and pi, and you can say 2 pi, right? Because we're not restricted, but 0 and 2 pi are in the same spot. So what do I do when they're across from each other?
You do plus pi n.
Write your smaller one and put plus pi n. So my 9x over 2 is equal to the smaller one, which is 0, plus pi n.
That's what we put.
Now, this is one of the very few times we can actually combine those. What is 0 plus pi n?
Pi n.
So 9x over 2 equals pi n. Now solve for x. Multiply by 2. So 9x equals 2 pi n. and divide by 9. So we find x equals 2 pi n over 9, where n can be any integer. Uh-oh, I leaned as I was going down there. All right, so what about sine of 3x over 2 equals 0? Same thing. Sine is which value, x or y?
Y.
Y. So again, we're looking for where y is 0.
0.
So 3x over 2 is going to equal to 0, and then plus pi n, right? Because it's in the same locations. It's at 0 and pi. I'm going to combine those. So 3x over 2 equals pi n, and then just get x by itself. And so x equals 2 pi n over 3, where n is an integer.